I want to reiterate some things I said about the block structure of C earlier. Statement blocks can hide variable definitions inside them. Remember when we had an integer I that was above a statement block, and then we did an if and went down inside it and we created another I? Well, that inner I that was created inside the statement block was completely separate from the one that was above it. So statement blocks can be containers and encapsulate some other information down inside them so that that information is not modified by or referenced by higher functions above it, or higher functionality, I should say, not to confuse that with functions. When you start to look at C++, you're going to see some of these kinds of concepts occurring with encapsulation and private variables and things that you can't get to from the outside world. So keep an eye out for that sort of thing. Identically named variables within other functions will be hidden down in there. Now let's take a look at this little piece of code here. Here we have an integer x and an integer y. We know that those are externs because they're declared outside of f of our function, or they're externals. If we needed to declare them someplace else, we would of course use the extern keyword. But here we're defining them as integers x and y, so we don't use the keyword. Now here we have f, which is going to take a double value, a floating point double of x as a parameter passed into it. This x will become a local automatic variable only contained within the function f. It will not be and is not a reference to this integer x out here. This is a whole different animal. Down in here we have a new local called y, which is also cast as a double, typed to be a double, and it is set equal to the value of x that was passed in here. This y and x have nothing to do with that one, because we have created new definitions down here, new y's and x's, and are not relying on these definitions outside this brace. That's the door. That's the container, or the open and the closed braces, which separate us off from this x and y here. And here we're going to return y times x. Now f would have had to have been defined as returning a type double, because if we don't say so, it's just going to return an int. And y times x are both doubles, and it's going to be a problem because we're going to strip some data off of there, strip a whole bunch of bits off of it when that double value gets shoved through an integer return path. So this is what we want to show you in block structure, and reiterate that the C language is not a specific block language like a Pascal, but it does in fact have the block structure somewhat by using these braces.